The first capacitor was invented by Peter van Muizenbroek in 1746 in the Holland city of Leiden, so they became known as Leyden jars. A Leyden jar capacitor can store quite a bit of charge, and Muizenbroek discovered that very painfully. The expression catching lightning in a bottle to describe something that is impossible or very dangerous to do comes from Ben Franklin flying a kite in a thunderstorm and trying to catch electricity, lightning, in his Leyden jar. I am going to show you how I constructed this Leyden jar and then show you some more sparks. The Leyden jar, just like any large capacitor, can be dangerous. They can deliver a very painful or even lethal shock. Here are the parts I'm going to use to build a Leyden jar. I have a lamp finial, a piece of welding rod, a glass jar that has a wood lid, and I have aluminum and copper tape. So these are strips of thin copper or aluminum with an adhesive backing. I've cut a piece of the aluminum tape that I will put around the inside of the jar as the inside conductor of our capacitor, and I've cut a piece of the copper tape that I will put around the outside of our jar as the outside conductor of our capacitor, and of course the jar will be the insulator between the two conductors of our capacitor. I've put the aluminum tape around the inside of the jar. And now I've placed the copper tape around the outside. So you can see the aluminum inside conductor and the copper outside conductor of our capacitor. I have my lamp finial in a vise, and I'm going to put in my welding rod and then melt solder around it to hold it in place. Here I have the electrode. I will now drill a hole through the wooden lid to the Leyden jar through which I can place the electrode. I've used some electrical tape to hold the electrode in place, and now I will solder this wire to the bottom end of the electrode and tape it to the aluminum inside the Leyden jar to connect the electrode to the inner conductor of the capacitor. Here is our finished Leyden jar capacitor. Here I have a Van de Graaff generator. Let me turn it on. The Van de Graaff generator has a small capacitance. Capacitance is the ratio of the charge on an object to its voltage. So even though the generator was charging up to 100,000 volts, there was very little current in those discharges. I could tell there were discharges, but it was a mild feeling. A capacitor consists of two conductors. So the way to think of the Van de Graaff generator is this globe here is one conductor, and the other conductor is wherever the electric fields emanating from this globe terminate, which are going to be a long distance away. It will be whatever metal structure it eventually encounters. Whereas for our Leyden jar, the two conductors are just separated by this thin piece of glass from the jar. The Leyden jar capacitor we constructed has about 1,000 times the capacitance of our Van de Graaff generator. So I don't want to feel the sparks from our Leyden jar. I'm going to use the Van de Graaff generator to charge our capacitor. I've connected a wire from the Van de Graaff generator to the electrode that attaches to the inside conductor of our capacitor, and then I have a wire attached to the outside conductor, which I will hold and act as ground. I'm not going to let the Leyden jar charge up to the full voltage of the Van de Graaff generator. That would take a long time because the Van de Graaff generator produces a small current. But after it's charged for a while, I'm going to take this electrode that's attached to the outer conductor and bring it closer and closer to the electrode attached to the inner conductor until the electric field intensity between the two electrodes reaches the dielectric breakdown strength of air, and we will get a spark. The sparks we were getting from the Leyden jar were much more intense than the sparks we were getting from the Van de Graaff generator because there was a lot more charge on the capacitor, and so there was a lot more current in those sparks. I also had to get much closer to get breakdown of the air because the voltage is lower. With the Leyden jar connected to the Van de Graaff generator, it takes about 1,000 times the charge to get to the same voltage as just the isolated Van de Graaff generator, and I wasn't waiting for that to happen. As the two electrodes are approaching each other, the voltage is being dropped over a shorter and shorter distance. So the electric field intensity between the two electrodes is increasing. Eventually, the electric field intensity gets so large you get field emission. Electrons are pulled off the negative terminal. These electrons then are accelerated by the electric field intensity towards the positive terminal, but they keep colliding with oxygen and nitrogen molecules, giving off some of their kinetic energy, but eventually reaching the positive terminal. This is a very small leakage current and would take a very long time to discharge our capacitor. As the electrodes get closer, the electric field intensity continues to rise, resulting in a greater force on the emitted electrons. So the emitted electrons will accelerate more before they collide with an oxygen or nitrogen molecule. That kinetic energy eventually gets large enough so that when the electron collides with an oxygen or nitrogen molecule, it knocks an electron off, ionizing the molecule. These two electrons then are accelerated, and they too will collide with an oxygen or nitrogen molecule, knocking off electrons and ionizing the oxygen and nitrogen molecules with which they collide. This multiplication that occurs from the initial electrons plus all the ions make the region between the electrodes very conducting, and you have a very quick discharge of your capacitor. Once the capacitor is discharged, all the electrons and ions recombine in this region, giving off that energy as light. That's the spark you see. In addition, the rapid discharge caused a lot of heating in this area, and the expanding air caused a pressure wave that you hear.